In a square, the two diagonals are equal in length and the two diagonals bisect each other at right angles. And we have to prove the same. So we have a figure ABCD, and if we draw the two diagonals, that is BD and AC, we'll first see the proof that the two diagonals bisect each other. So if the point of intersection of these two diagonals is O, and if we name these angles, let this be angle 1, this be angle 2, this be angle 3, and this be angle 4, then if you look at this triangle AOB and triangle COD, then you will see that this angle 1 is equal to angle 2. Why? Because two parallel lines and they're transversal. So this is A, this is B, this is C, this is D. The transversal is AC for these two parallel lines AB and CD. This is angle 1 and this is angle 2. So angle 1 is equal to angle 2. Alternate interior angles are equal to each other. Then this side AB is equal to this side CD. That's a property of a square. So AB is equal to CD. Then this angle 3 is equal to angle 4. The same, that the alternate interior angles are equal. If you want to see it, this is AB, this is the transversal BD, and this is DC. So A, B, D and C. Angle 3 is equal to angle 4. This is a transversal. So angle 3 is equal to angle 4. So A, S, angle, side, and then again angle. From ASA criterion, we can say that these two triangles, triangle AOP and triangle COD, are congruent. Now, we have proved that these two triangles are congruent, and if you take these two triangles, so if we draw these two triangles, this is triangle AOB and this is triangle COD. Now, this angle 3 is equal to this angle 4, right? Or we can say that angle B is equal to angle D. This angle A is equal to angle, this angle 1 is equal to angle 2. So we can say that angle A is equal to angle C. Therefore, since these two triangles are congruent, therefore the third angle will be equal to each other. The remaining third angle will be equal to each other, right? So if you take this triangle, and imagine that you are holding this triangle in your hand and you want to superimpose this triangle on this triangle COD. Then since this angle B is equal to angle D, therefore this vertex B will fall on this vertex D, or say that fit on this vertex D. This vertex A will fall on this vertex C, that is, it will fit on this one, and the remaining, this vertex O, will fall on this vertex O. The corresponding vertices is B of AOB and D of triangle COD, then A of triangle AOB and C of triangle COD, and then O of triangle AOB and O of vertex O of triangle COD. These are three pairs of corresponding vertices. So since this B will fall on D, and therefore we can say that BO will fall on DO. So BOO of triangle AOB, BO of triangle AOB will be equal to this DO of triangle COD, and then since vertex A will fall on vertex C, therefore AO will fall on CO. So AO of triangle AOB is equal to CO of triangle COD, and the remaining one is what? The remaining one is that this AB is equal to CD. So AB is equal to CD. But we have to take only these two. So from here we can see that BO is equal to DO. So this BO is equal to DO, and AO is equal to CO. AO is equal to CO. So we have proved that the two diagonals bisect each other. Now we will prove that the two diagonals which bisect each other, they bisect actually at right angles. Okay. So for that, what you have to do is you have to take triangle AOB and triangle AOD. Triangle AOB and triangle AOD. Now, AB of this triangle AOB is equal to AD of this triangle AOD, because in a square all the sides are equal. Then this side AO is common, so AO is equal to AO since it is common side. And then this BO is equal to DO we have seen here, right? From here, since the diagonals bisect each other. So BO is equal to DO. So from this we can say that it's S, S and S. From SSS, that is side criterion, we can say these two triangles are congruent. Okay, so these two triangles are congruent. Now this is triangle AOB, this is triangle AOD, sorry, and this is triangle. We have separated these two triangles just to make you things clear. And this is triangle AOB. Right? Now, if you see this one, if you take these two pairs, that is AB is equal to AD, and this is BO is equal to DO. Here we have to tell the corresponding vertices. This is SSS criterion. Whenever you face SSS criterion, we always take any two pairs of equal sides. Like in this case, we have taken AB is equal to AD and BO is equal to DO. This AB and BO belongs to this triangle AOB, and this AD and DO belongs to triangle AOD. In SSS criterion, most of the students make mistake when they have to tell the corresponding vertices. Right? So I'll tell you, take any two pair of equal vertices, equal sides. I have taken this one and this one. You could take even these two or these two. Now, on the left hand side, this belongs to triangle AOB, right? Tell me which vertex is common. You will say this B is common. Very nice. And tell me on the right hand side that belongs to this triangle AOD. Tell me which vertex is common. You will say that D is common. So B of triangle AOB and D of triangle AOD, these are corresponding vertices, and then same thing is here as well. And then the remaining one is what? A and A. It means that vertex A of triangle AOB will fall on vertex A of triangle AOD. These are the corresponding vertices, and then O of triangle AOB will fall on O of triangle AOD. These are corresponding vertices. So we have got three pairs of corresponding vertices. And why is it important? It's important because now from here you can see that the B of this triangle will fall on D of this triangle. A of this triangle will fall on A of this triangle, and O of this triangle will fall on O of this triangle, right? It means what? It means that angle B, this angle, since this B vertex fall on vertex D, this angle will be equal to this angle. Just imagine that you have placed this triangle exactly on the top of this triangle. It has completely fallen on this triangle and it's covering completely. So angle this B is equal to angle D. Excuse me. This angle is equal to this angle. It's completely covering this one, and this AOB will be equal to AOD, and that's important. We have proved here that angle AOB is equal to angle AOD, right? And it's only due to the congruent property of the triangle. So this angle AOB is equal to this angle AOD. We have proved here. What does that mean? It means that if you look at this angle, actually the whole, it's a linear pair, because this angle and then plus this angle, these two angles are forming linear pair, and therefore the sum will be equal to 180 degrees. So angle AOB plus angle AOD, this is equal to 180 degrees. Now, since angle AOB is equal to angle AOD, let's suppose that both these two are actually equal to x. Let's say that this is actually equal to x. So x plus x is equal to 180 degrees. From here you get 2x is equal to 180 degrees. And from here you get x is equal to 90 degrees. Now since x is equal to 90 degrees, you can see that this is at right angle and this one is also at right angle, right? So 90 degree and 90 degree. So this one will also be 90 degree. Why? Because now you can see this one as a linear pair. So this one is 90, so this one will also be 90 degree. And same thing here. If this is 90, and if you look at this one, this is forming a linear pair. This one will also be a 90 degree at right angle. So we have proved that the two diagonals which bisect each other, they bisect each other at right angles, right? Now the last one is that we have to prove that the two diagonals are equal in length. So what you have to do is draw the two diagonals, that is this BD and this AC, and now take triangle ADC, and then take, so let me write here, and then take triangle BCT. Right, so we have taken triangle ADC and we have taken triangle BCT. ADC and this is triangle BCD, right? This AD is equal to BC. So first let's write triangle ADC and triangle BCD. This AD is equal to BC, so AD is equal to BC. Then this angle D is equal to angle C is equal to right 90 degrees because this is a square. So angle D is equal to angle C is equal to 90 degrees. And then this side DC is equal to side CD since this is common. Can you see here? This side is actually common, right? This side is common. And that's what we have here. So DC is equal to CD. DC of triangle ADC is equal to CD of triangle BCD. Now, we have we have S, two sides equal, then we have the angle equal, and then we have side equal. Side, angle, side. Side, angle, side. From SAS criterion, we can say that these two triangles are congruent. Now, since these two triangles are congruent, if this side is equal to this side is equal to this side, therefore the remaining side will be equal to this one. That is, AC is equal to BD. AC is equal to BD. That is, AC is equal to BD. The two diagonals are equal. We have proved here. So hence proof that the diagonals bisect each other at right angles and the diagonals of a square are equal in length.